Have you ever disagreed with someone? It happens a lot. They believe they're right, you believe you're right. They try to convince you, you try to convince them. But have you ever asked yourself, where does your evidence really come from? How certain can you be about any of this? Lots of arguments can be settled by simply looking something up, but what about things you can't look up so easily? How do we answer those questions? Now, most people know that science is knowledge about the natural world based on evidence and discovery. In school, we spend a lot of time reading about it. But did you also know that you can do science, collect your own evidence, and create knowledge? In fact, you might be doing science right now, even if you didn't know it. The process usually starts with something we observe about our world. These observations lead to questions and predictions. Questions can be tested, and what we get from these tests is called data. We can use data to decide if our original predictions were accurate or if something else might be going on. Science is a special way of knowing. If we can observe, measure, quantify, and analyze something objectively, then it can be used as evidence to prove or disprove something. We call things like ghost hunting an example of a pseudoscience because it relies on evidence that is very subjective in nature and hard to prove or disprove. The process of doing science might also reveal new questions for us to look into. Sometimes, in order to do this, we need to draw from what we know about other areas of science. Collaboration with scientists who are interested in answering other types of questions and finding other types of evidence is essential to doing science. It's also an important part of how our evidence gets verified. You see, when a scientist wants to publish their work, it first has to go through a critique known as peer review. In this process, the work is submitted and scrutinized by other scientists and science institutions. If everything looks good, then the work gets published and becomes knowledge. If problems are found, then the scientists will need to collect new, stronger evidence before they can reapply. Science is not only very tricky about accepting new evidence, but is also finicky on how scientists communicate what they know. Science knowledge is always, to one degree or another, an uncertain business. Nature adapts and changes. Real life is not always 100% predictable. We're always learning new things. The way we approach knowledge of science should reflect this. Scientists can only be reasonably certain and confident when they have the evidence to back up what they know. The bigger the claim, the bigger the evidence needed to support it. If a scientist were to put the cart before the horse and make a claim without sufficient evidence, this would hurt their standing. With scientific evidence, accountability is just as important as accuracy. Even if the evidence provided by science is only one slice of the pie to consume when we make decisions that impact our lives and potentially the world, it is an invaluable one that really needs to be handled with care.